All right, welcome. In this video, we are going to talk about the concept of the mole. And we're going to look at some examples with mole and molar mass and what that means. So what is a mole? A mole is a unit used to count number of atoms or molecules or anything. And a mole of atoms is 602 sextillion atoms. So that's this number right here. It is a very big number. And if you think about this number, it's a similar concept to a dozen. So if you say you have a dozen eggs, that means you have 12 eggs. A dozen marshmallows is 12 marshmallows. A dozen carbon is atoms or 12 carbon atoms. So that word dozen has a specific, number associated with it. Same thing with a mole. If you say you have a mole of eggs, that means you have 6.02 times 10 to the 23rd eggs. That is how we write out this really big number in scientific notation. It's basically a 6 with 23 zeros after it. If you have a mole of marshmallows, it's that many marshmallows. If you have a mole of carbon atoms, it is 6.02 times 10 to the 23rd carbon atoms. So a mole means 6.02 times 10 to the 23rd. And that is a really big number. And so we want to try and kind of come up with some analogies to help us conceptualize how big it is. So if you had a mole of basketballs, then they would take up the size of the earth. That's how much a mole of basketballs would be. If you had a mole of marshmallows, it would cover the entire United States to a depth of 650 miles. If you had a mole of something even smaller, like grains of rice, it would still cover all of the land on the earth to a depth of 75 meters. So a mole is a super big number. But atoms are really small, and so are molecules. So a mole of an atom or a molecule is actually a really reasonable amount. So some examples here, a mole of water weighs 18 grams, and that's about like 2 tablespoons of water. So that's actually a really reasonable amount of water. It's not very much, right? A mole of copper is about 63 grams. That would be around 22 copper pennies. So atoms are super small, so a mole of atoms is actually a reasonable number. And there's a relationship between moles and mass. And if you look on the periodic table, we find the average atomic mass, right? So if we look at hydrogen on the periodic table, its average atomic mass is 1. And it turns out that a mass of 1 mole of hydrogen atoms weighs 1 gram. So what we're saying here is a mole of hydrogen atoms weighs 1 gram. Carbon, if you look on the periodic table, it has a average atomic mass of 12.01. So remember, the way that we find this on the periodic table is we look over here, and it's the number on the bottom there that is the average atomic mass, and that is how much 1 mole of carbon atoms weighs. So what we find here is there's a relationship, there's a mass ratio here. There's a relationship between how many moles you have and what it weighs. So that's really helpful. So like a mole of iron atoms weighs 55.85 grams. Okay, so we call this number the molar mass. So if you look on your periodic table, that number on the bottom, which we've been calling the average atomic mass, we can also think of it as the molar mass, or the number of grams per 1 mole. So what this tells us, again right here, like for mercury in this example, is that 1 mole of mercury atoms weighs 200.6 grams. So how we usually write the units of this is we'd say that the molar mass of mercury is 200.6 grams per mole. So that's how we write out gram/mole. That would be, you would say it as grams per mole. So we can look on the periodic table and find the molar mass of these elements. So you can pause the video and try this on your own. But if you look on the periodic table, like for nitrogen, its box looks like this. So that number on the bottom is the molar mass. So nitrogen has a molar mass of 14.01 grams per mole. Neon, if I find this on the periodic table, it has a molar mass of 20.18 grams per mole. Chlorine is 35.45 grams per mole. And then copper is 63.55 grams per mole. So that number on the bottom is the molar mass. And what's helpful here is this concept of molar mass allows us to count the number of atoms in a sample just by weighing it, right? So if we have a sample of carbon, so here's a sample of like carbon in the graphite form, we could weigh it and then know that, well, every, 1 mole of carbon atoms weighs 12.01 grams, and we can use that ratio to figure out how many carbon atoms are in our sample. So we can count by mass is what we call it. So counting by mass. So we can use this ratio to figure out how many atoms are in something based on its mass. Another example, you could weigh a sample of water and figure out how many water molecules are in it. So if you had 18 grams of water, we would know, hey, that's 6.02 times 10 to the 23rd water molecules. So here's a couple of application problems. Using your periodic table, identify which one has more mass. So a mole of hydrogen or a mole of carbon. So here what we're doing is we're just comparing the molar masses. So if you look on your periodic table, a mole of hydrogen weighs 1.008 grams, and a mole of carbon weighs 12.01 grams. So a mole of carbon is going to weigh more. So I'm going to circle the right answer here. If you look up aluminum, here's what aluminum looks like on the periodic table. It's got an atomic number 13. Its molar mass is 26.98. Iron looks like this. Iron is element 26. It's got a molar mass of 55.85. So 1 mole of iron is going to weigh more. Okay, it's going to have a higher molar mass. A mole of copper, if you do the same thing, copper looks like this. It's element 29. It's got a molar mass of 63.55. If you find gold on the periodic table, its atomic mass is 196.7. So again, what that means is 1 mole of copper weighs 63.5 grams, whereas 1 mole of gold weighs 196.97 grams. So a mole of gold is going to be heavier. That's what this kind of question is getting at here. Just as a quick reminder, remember the number on the top represents the number of protons. And we're not using that for right now. I just want to remind you. Okay, in this last one, we're comparing different amounts. So a mole of gold would weigh 196.97 grams. That's the one we just looked at over here. And then we want to know, well, what about how much would 5 moles of carbon weigh? Well, we know that 1 mole of carbon would weigh 12.01 grams. We see that on the periodic table. So 5 moles would weigh 5 times that, 5 times 12.01. So that's going to be about 60 grams. So which one weighs more? It's still gold. So basically gold is more than 5 times heavier than carbon. So a mole of gold is still heavier than 5 moles of carbon. Let's look at the other way. So what we did here is we were comparing samples of moles and asking which one had more mass. And now we're going to kind of do the opposite. We're giving masses and we want to compare which one has more atoms. So again, we're going to use our periodic table. And if we look at hydrogen, hydrogen has a molar mass of 1.008. And carbon has a molar mass of 12.01. And we want to compare which one has more atoms. Well, 12 grams of carbon is about 1 mole of carbon. Okay, so that contains 6.02 times 10 to the 23rd atoms. 12 grams of hydrogen, that's a lot more than a mole. Right? Because a mole of hydrogen only weighs 1 gram. So if I have 12 grams, that's a lot more. I seem to have about 12 moles of hydrogen atoms. So this is going to be more than a mole. We could calculate what it is exactly, but we don't have to. We just need to know that it's more than a mole. So 12 grams of hydrogen is going to contain more atoms than 12 grams of carbon will. And there's a couple different ways you can look at a problem like this to reason through it. Another thing you could think about is you could say, well, hydrogen atoms are lighter than carbon atoms, so it's going to take more hydrogen atoms to reach 12 grams than it would carbon atoms. So that's another way you could reason through a problem like this. Here's another problem, 27 grams of aluminum versus 27 grams of iron. So if you look at aluminum, again, aluminum has a molar mass. Here's aluminum, it's Al. It's got a molar mass of 26.98. If you look on the periodic table, iron has a molar mass of 55.85. So if you have 27 grams of aluminum, that is 1 mole of aluminum. So that's 6 times 10 to the 23rd atoms of aluminum. If you have 27 grams of iron, that's less than a mole, right? Because a mole is like 55 grams. You only have 27 grams. So that is less than 1 mole. So it's less than, 6 times 10 to the 23rd. How much is it exactly? We don't have to calculate it. We just need to know it's less than a mole. So who's got more atoms? The 27 grams of aluminum is going to have more atoms. And again, you could still use the other logic we talked about here. We could say, well, aluminum atoms are lighter, so you need more of them to get the same amount of grams. That's another way you can kind of think of it. Here's a couple more examples here. Let's look at, so 40 grams of calcium. 1 mole of calcium weighs 40 grams. Whoops. So if you have 40 grams of calcium, that means you have about 1 mole of calcium. And then sodium, if you look at sodium's molar mass, a mole of sodium weighs 23. So 40 grams is more than a mole. So what that means is your sodium, you have more sodium atoms than calcium atoms, because 40 grams of sodium is more than a mole of sodium. Down here again, 40 grams of calcium is about 1 mole of calcium. We just talked about that one. And then 60 grams of zinc. Well, 1 mole of zinc is 65.4 grams. So you don't have a mole of zinc. You have a little bit less than a mole. So 40 grams of calcium is 1 mole of calcium. 60 grams of zinc is a little less than 1 mole of zinc. So who's got more atoms? This one over here. So you can kind of see what our process here. We're just kind of trying to use this idea of molar mass. And then here's kind of a last check-in question here. Compare the number of atoms in 1 mole of copper and 1 mole of iron. Okay, well, if you have a mole of copper and a mole of iron, they both contain the same number of atoms. Because a mole means a certain number of atoms, and it doesn't matter what you're talking about. It could be copper, it could be iron, it could be hydrogen, it doesn't matter what. So a mole always means 6.02 times 10 to the 23rd atoms. So these two things have the same number of atoms. If you're comparing the masses, though, the masses would be different. So in this case, we're comparing the mass of 1 mole of aluminum versus 1 mole of carbon. So the mass of 1 mole of aluminum would be about 27 grams. 1 mole of carbon would weigh about 12 grams. So while these two things would have the same number of atoms, they are going to have different molar masses, and that's because individual atoms of aluminum are heavier than the individual atoms of carbon. So that's a little bit of an overview of the idea of moles. And in other videos, we'll talk through some mole calculations.